Hello everyone, in this video we will be discussing probability. We will begin by defining the words possibility and probability. Possibility, which in Greek translates to endochomeno, means something that is possible, right? So if something can happen, it's a possibility, right? Probability, which in Greek translates to πιθανότητα, means how probable a possibility is. How likely is it to happen? Is it very likely? Are we almost sure it's going to happen? Or is it very unlikely? So we don't really think it's going to happen. Often these two words get confused in both languages, and they are not the same, and you should know the difference. So again, possibility, if something is possible, if it can happen. Probability, how probable is it? So how likely is it, basically? The probability of an outcome is shown as a fraction. So let's say I do an experiment, right? And we ask, what is the chance, what is the probability that I get this result, right? That probability is going to be written down as a fraction. The numerator of that fraction is going to be the number of possible outcomes where the desired conditions are met. So let's say my experiment is a coin toss, right? So in the coin toss, for example, desired conditions might be something like getting tails or getting heads. Those are the only two possible conditions, really. So in this case, if I asked you, what is the probability of getting heads in a coin toss, you would start with a fraction that has a numerator of 1. The denominator is the total possible number of outcomes. So the total possible number of outcomes in a coin toss, in a coin toss, sorry about that, is 2. You can either get heads or tails. So again, if we were doing a coin toss, right, there are two possibilities, heads or tails. And if I ask you, what is the possibility of getting tails, you should consider that the conditions I have set are met only if you get one of the two conditions, tails, not heads, tails. And so the probability would be 1/2, 1 out of 2 conditions satisfy the terms I set, basically, which is getting tails. So that means that all probabilities have a range from 0 to 1. 0 meaning that the conditions I set are impossible, and 1 meaning that they are certain, right? So for example, in the coin toss example, right? Let's say I asked you, what's the probability that the coin disappears into thin air? Like you just toss it and it just vanishes, right? You should say 0 because that's not a possibility. That can't happen. But if I ask you, what's the probability of getting either heads or tails, your answer should be 1 because those are the only two results you can get. You're going to get one of those two results. So it's absolutely certain that you're going to get one of the two, right? Where we see this very often, probability coming into play, is with dice, right? So here I have made a dice that you can see as it normally is. Here is how it would be if I broke it apart so that we could see all of its sides, right? So 1, 2, 3, 4, 5, 6. And I haven't placed the numbers as they should be, but that doesn't really matter. When I roll a die, there are only 6 possibilities that we can get. We can get 1, 2, 3, 4, 5, or 6. There's nothing else really. There are no other possibilities. I'm going to get one of these 6 results. So let's say that someone gave us a die and they asked us the following questions, right? What is the possibility that I roll a 4? Well, as we said, our answer should be a fraction, right? so a fraction, and the numerator is going to be the number of possibilities where these conditions are met. What are the conditions? That I roll a 4. How many possibilities fit that description? Well, only one. Only one. So my numerator is going to be 1. And then for my denominator, we have to think how many are all the possibilities. And the answer to that is there are 6 of them. So 6. So my answer here should be 1/6. Because in 1 out of 6 possible outcomes, do we get the requested conditions that I roll a 4. The next question is, what is the probability that I roll a 6? Well, this is the same thing again. We only have one result in which we meet the conditions of rolling a 6. If you ask for any one of these numbers separately, you're always going to get the same answer, 1/6. Because in 1 out of 6 outcomes do we get the result that you want. But we can also get an answer like something completely different. So here, for example, we're being asked, what is the probability that I roll a 0? Well, there is no possibility of rolling a 0. You're always going to roll one of these 6 numbers, right? So there is no probability of rolling a 0, meaning that our answer here should be 0 because this is impossible. Now careful, because you might get confused if you see an answer like this, a question like this, which asks, what is the probability that I roll a 7? You might think, oh, well, that's more, and that's more than 6, so my answer here is going to be 1, right? Because that's the other side of the range. Well, no. Because again, what is this asking basically? How many are the possibilities, right, where I roll a 7? And the answer is 0. There is no possibility in which we roll a 7. We can either roll 1, 2, 3, 4, 5, 6, or 6. There is no possibility of rolling a 7, at least not with this dice. So the answer here should be 0, because rolling a 7 is impossible. Then look at the next question. The next question asks, what is the possibility that I roll a number greater than 0? We want all the possibilities where we roll a number greater than 0. Is 1 greater than 0? Yeah. Is 2 greater than 0? Yeah. 3 also. 4 also. They're all greater than 0. So in all 6 possibilities, I have rolled a number greater than 0. So the probability of rolling a number greater than 0 is 6 out of 6, because in all 6 possible results, I meet the conditions that are set for me. Conditions being that I roll a number greater than 0. I meet them in all 6 possible results. Next, we get a one that's a little more complicated. It asks, what is the probability that I roll a number greater than 2? Greater than 2. It has to be more than 2. Well, 1 doesn't qualify, so no, we don't want this result. 2 doesn't either, because it has to be more than 2. It can't be 2. But then all the other results are perfectly fine. So in 4 of the 6 possibilities, we can roll a number that is greater than 2. So the probability of that happening is 4 out of 6. Because in 4 out of 6 possible outcomes, we get what we want, a number greater than 2. Next question is asking, what is the probability that I roll a number smaller than or equal to 3? So a number that is less than 3 or equal to it. So 3 counts, and all the numbers that are less than 3 count. That means that 3 out of the 6 possibilities are the desired outcome. So 3 out of 6. So the probability of rolling a number smaller than or equal to 3 is 3 out of 6. Because 3 of the possible outcomes meet the conditions that I set. If I said smaller than or equal to 4 would be 4, because this would count as well, 4 out of 6. Now this gets, this is all we're going to explore for now, because I imagine that just this might be confusing enough. But I do want you to know that it can get a whole lot more complicated, especially just to make this example, show you how this example can get really a whole lot more complicated, is what happens if we introduce a second die. Now what are the possibilities? Well, it changes completely, because the outcomes are no longer just 6, because the combinations of the two dice are different outcomes. So for each result of one dice, I have 6 other possible results for the other dice. That makes a total number of possibilities of 36. I have 36 possible outcomes, basically, if I have two dice. But we're not going to explore that today at all, or generally speaking this year. So that'll be all for today. I will see you guys again on Friday's video. Have a good week. Bye.